Hi everyone, welcome back. Okay, there's a common question and we want to prove it's true. So by the way, if you wanted to, you could put in 10 degrees, 20 degrees, 10 degrees, 20, be a bit yucky and minus. Say 30 degrees, 10 degrees, 30 degrees, 10 degrees, put in 30, 10, 30, 10, and you could show that they're all equal. But before we go any further, I just want to make sure I didn't make any mistakes. I didn't. So what are you going to start with, the left hand side or the right hand side?
Left.
You know what, this question I like both. That's why I talk about the, what do I call it? Starts with B, U, M. Bumbling approach. So, if you looked at the solutions to our textbooks and it's got lots of these, they have this perfectly presented, beautiful solution. Yeah? Now, we're not all going to do it perfectly. So let's start with the left hand side and what we're going to do. That's A and B and that's A and B. So we can go cos, sin. You okay with that?
Mm-hmm.
The bottom I can go cos, sin. And I want to get something like that. But it's not going to be anything like it. Let's put the letters in. Theta, alpha, theta, alpha, theta, alpha. What am I using the alpha for? And a plus when you have a cos becomes a
Minus.
and the minus becomes a plus. Does that look like the right hand side?
Yes, it does.
Well, yeah, because they could be converted to tan, but I don't know how.
Wait, no. Huh? Because there's a tan on the both of them.
So if I divided that by itself,
Oh wait, there's a cos over
Give you one.
right, I'd get that one. Now, I know that's going to muck your brain up, but I could do this, ready? If I divide, now right here, 1 over, this is my times by 1 again, over and over and over again, times by 1. So, I'm going to times by 1 on cos theta, cos alpha. What am I going to do that for? Because I know I want a 1 there. If I times the top by that fraction, what have I got the times?
The
The bottom by that fraction. And now you're understanding that a lot better than before. And why would I do that for? Experience. What do I write over and over again? Equals f times 1. We're not solving, so we don't need equal 0. Have we got fractions? We probably need fractions. And we are factorise, possibly. I want times by 1. So what's that times 1 over itself? So there's a bracket there. If you wanted to remember, a fraction bar means brackets. That times that is 1.
I don't get how you're allowed to times it though.
How do we answer that?
Like, I'm not comprehending how you can just pull that in. I don't know
I'll
why.
go back to my $100 and times it, $1,000 and times it by 2 over 2 again. What if I did this, right? I'm going to do this there. I'm going to rub this off in a moment. This is going to be important. If I had $1,000 in my bank account and I decided to divide times it by 1 over 1,000 over 1 over 1,000. What does it do to my $1,000?
Nothing.
Doesn't change it, does it? If I multiplied the top, I'd have it ready through. 1,000 on the, no, this is going to cause more confusion. Over 1 on 1,000. That's still 1,000.
How?
Why is it still 1,000?
1 divided by 1,000.
1 divided by 1 on 1,000. How many times does 1,000 go into 1?
1,000.
So it's still 1,000. But I turned it from something that was simple into something that was revolting. Noise next door. How do I get through that? Yeah, why are we doing that? You see it, really?
We're just trying to get rid of things, right?
Yeah. Now, can I tell you the way I did think at school? I didn't do any of that. But as a teacher, when I told people what I did, a lot of people look at it and they say, I don't know what you did, ready? I'd go cos theta, cos alpha. And I'm going to divide that by cos theta, cos alpha.
Wouldn't that give you 1?
Yes, which is what I wanted. Yay!
So can't you just
So
pull
wait
that
a
one
minute.
out?
If I divided that by cos theta, cos alpha,
That's fine.
got to divide that by cos theta, cos alpha.
Why do you have to divide that though?
Well, I can't just divide that without dividing that. So if I had 10 minus 2 over 6 over 10 plus 2. If if I divided that by 10, I've got to divide that by 10, and I've got to divide that by 10, and I've got to divide that by 10. Let's go back to factorial. 2x plus 6y over 4x plus 8y. Am I allowed to cancel? We have how and y. 2 outside of x plus 3y, and that is, well, that's a go 2 outside of 2x plus 4y. I can cancel them. So if they're all even, and we've got additions or subtractions or whatever, just going back to fractions, I'm allowed to cancel everything in there by the same number. So I can cancel everything here by 10. So what can I cancel that by? If I divide that by that amount, I get the top, divide that by that amount, and then what am I going to do to the bottom?
The same.
Same. So that's cos theta, cos alpha, oops, over,
Cos theta, cos alpha.
cos theta, cos alpha, which is nice because it's going to just drop the answer out. Sine theta, sine alpha, what am I going to divide it by?
Cos theta, cos alpha.
Yeah. That becomes 1. What's sine over cos?
1.
10.
Oh, yeah.
What's sine over
That's
cos?
what I meant.
10.
What's that over that? 1. What's sine over cos? What's that over that? Which equals the right hand side, therefore true. So we've just proven that if you take that case, we can, instead of that, we could write that instead. Instead of that, we could write that instead. They're actually equal. I'd love to take our time and put in some numbers and show you that's true. Yes, mate?
I can follow that. I know what you're doing, but there's just no way I'm going to think of that in a test.
Yeah, but when you say there's no way you will, it's a self-fulfilling prophecy.
Mm.
So there's no way when I first looked at this, I don't know. So it's time. So you talk about stress, pressure, other subjects, time. How much time do you have to go over and get into your brain? Would your brain have thought of that? Just go that to that, and then would have looked at that? What's another way of doing the same question? Maybe Abby, maybe you need to see this, okay? I'm going to start with the right hand side and do the same question again. I'm going to write what? What can I write instead of that?
Sine over cos.
Sine over cos. And by the way, in that concept you didn't get a moment ago, trust me, I'll come back to it. And come back to it. And then I'll come back to it. And after I'll come back to it. So this will be sine, and you might look at this and go, oh, Mr. P, that was so much easier. Did some of you say to start with the right hand side first? Does it look yuckier? I don't know. 1 plus sine theta over cos theta. That's going to be sine alpha over cos alpha. What can I multiply that by to get rid of all those horrible fractions?
Cos.
I can multiply it by cos theta and by cos alpha on the top. And if I multiply the top, I multiply the
Bottom.
because then it's going to be times in by 1. Now here's the big leap. What's that times that?
Cos theta, cos alpha.
Are you seeing the answer in your head now, Ryan, to the whole question?
Kind of.
What's all that gobbledygook times that?
Wait,
Numerator
I
can
thought that's what
cancel.
you just did.
Sine theta, sine alpha.
Yeah, that'll cancel with that. You say that again?
I thought that's what you just did down there when you.
No, ready, here's a bracket.
Yeah.
If I had 1 minus 3x times by 4, expand the brackets for me.
4 take 12x.
Yeah, I'm going to multiply 4 times the first term and 4 times the second term. There's the first term. All of that is the second term.
Oh, okay.
So I'm not only going to multiply the first term, I'm going to multiply the,
Second.
and then that cos will cancel that cos, and that cos will cancel that cos, and I've got sine theta, sine alpha. So this is really important to take my time with it. Because now it's done easier than the other method. Probably. You're starting to see it? There's our bad. Which is that. We've nearly got the question done. So this one times by that. So 1 times that is going to be?
Cos theta, cos alpha.
Yeah, cos alpha.
Sorry, Abby.
You're all good.
Plus, the cos cancels, you've got sine theta, sine alpha. And there's your A, B, cos, sine, sine. So what's A, B, cos, sine, sine? Cos of?
Theta plus
Theta alpha.
Yeah, and so you haven't had a lot of time to take them in as yet. Cos, sine, theta, alpha is. Cos of, theta, alpha, and the plus becomes a minus, which equals the left-hand side. You don't always have to start with the right-hand side, you can start with the left-hand side, you can start with it. And sometimes I start with the left and I start with the right. Is that done? You okay?
Yeah.
So it's proven it two ways. So see here, I times by that and that and that and that. When I did it starting from the left-hand side, I had to times by that and that. And that did your heading. Still probably does your heading. I want to do something like, I don't know, I feel like I want this. I had that. I decided to times that by 1 on x. Oh, maybe this is it. Sometimes things come out of my head and I don't know what that's happening until it comes out. That sounds shocking. Like I don't know what I'm thinking until I say it. No, it just happens. What do? That times that times that. Why? Because it's a bracket. 1 minus x times by 1 over x. Expand it for me. Just you.
1 take x over x.
1 over x. That times that is?
1 over x.
And x times that is?
Negative. Oh. Yeah.
So that times that is 1 over x.
Mm.
That times that is 1 with a minus. So we've got 1 over x minus 1. What's this one? That times that, brackets.
1 over x.
And that times that, brackets.
Plus 1.
Yeah. So if we wanted to, I could turn 1 minus x over 1 plus x into that. Is that useful? What if I wanted to turn that back into that? I'm going to times it by x over x. Brackets. That times that times that. What do I have?
1.
Yeah. Minus.
Take 1x.
Yeah. Don't have to write the 1. That times that.
1 plus x.
Yeah. So you can go backwards and forwards and inside and out. Here's the stupid part. In math, we're teaching you to do this weirdo thing when you haven't come to grips with probably that as yet. Let alone timesing by it. Look what I times by here. You go, what the hell are you doing? You multiplied by that. Why? And you said, well, I'd never think of that. Well, you will maybe now. Not yet though. Go on, talk to me.
Can you split that fraction? Yeah, that one.
That one?
Can you split that into 2?
I could go.
And then can you cross multiply it?
No. When can I split a fraction into 2?
I don't know.
Well, that's
When it
important.
multiplies.
And this is really important for you to know. If I had 1 plus 7 over 2 plus 3, let's make it nicer. 1 plus 9 over 2 plus 3. What's 1 plus 9?
10.
What's 2 plus 3?
5.
We know that's 2. We know that's 2. Ready? How can I split the fraction? Can I put 1 plus 9 over 2 plus 1 plus 9 over 3?
No.
That's completely wrong. Because that's going to be 10 over 2 is 5, 10 over 3 is 3 and a third, which is definitely not going to give us 2. I still remember as a kid having to think fractions through, but I did so many fractions in year 5 and year 6 in Australia all those years ago that it literally was incredible how many we did.